Welcome to Math Infinity. In this video, I will introduce the cosine and sine of square matrix, and I will show that the cosine square plus sine square is equal to the identity. Alors, tout dessous, we need first to recall the power x series expansion of cosine and sine given by these two formulas. And as you can see, we can use this expression of cosine and sine as a sum to replace x and in by a square matrix. So indeed, if we take a square matrix, we can put that cosine A is given by this sum and the sine is given by this sum. Now we need to show, since this sum is infinite, we need to show that this expression is convergent. And to dessous, we take a multiplicative norm on the vector space of square matrix. We have this inequality which show that this series is convergent, and therefore the series defining the cosine is normally convergent and hence convergent. And we show that cosine A and sine A are well defined. With this definition, we will show that we have the identity cosine square A plus sine square A equal to the identity. And we will be down. To dessous, we need to first to suppose that A is diagonal. So if A is diagonal, then E power k is given by the diagonal of the power k of the entries of A, and hence we, by using the definition of cosine A and sine A, we get that cosine A is just the matrix diagonal with the cosine in the diagonal, and the sine is the same thing, and we get the desired formula. If A is diagonalizable, this means that A is equal P minus 1 dP, where D is a diagonal. We get that cosine A is P minus 1 cosine dP, sinus E is P minus 1 sine dP, and we get also the formula in this case. Now, for the general case, we compute cosine A square, and we get this double sum. We replace P plus Q by M and Q by M minus P, and we divide by 2M factorial to get the binomial coefficient and to get this formula. We will do the same thing for sine A square, and we will get that sine square A is this double sum. We replace P plus Q plus 1 by M, Q by M minus P minus 1, and we get the same formula as the cosine square A with the binomial coefficient. Now, if we take the sum of cosine a square and sine a square, we get this new formula. And now we will show that the expression between the round brackets is equal to 0 thanks to the binomial theorem. And we have shown that cos a square plus sine a square is equal to the identity.